To communicate craftsmanship today, luxury heritage brands are completely abandoning static imagery and adopting dynamic, time-based motion graphics. These deliverables are highly technical. Modern immersive items demand 8K resolution, 120 frames per second, and high dynamic range displays. This volume of data expands the mandate of the VFX supervisor. They can no longer simply critique final composites. They must engineer the technical pipeline required to build them. In the past, teams could evaluate isolated 3D renders on standard monitors. Today, those assets must exist within an interconnected photorealistic pipeline from the moment they are generated. Relying on manual file routing and destructive pixel workflows to process thousands of high-resolution assets introduces unacceptable rendering delays. Without a complete structural overhaul, standard production pipelines collapse under the sheer weight of 8K data. We refer to this as the scale crisis. When a sequence runs for 6 minutes at 8K, a single frame contains over 33 million pixels. If an artist has to manually update lighting passes, export them, and rebuild the composite for every client note, the entire facility stalls. This animated diagram illustrates the operational risk. Under strict episodic deadlines, a single broken file path cascades through the pipeline, invalidating days of rendering. Because traditional compositing bakes layers together, a request to adjust the texture of a single object forces the artist to rebuild the entire sequence from scratch. Resolving this bottleneck requires abandoning manual file handling entirely. The studio must pivot to a fully automated, non-destructive architecture. The first pillar of this new architecture is the Academy Color Encoding System, or ACES, managed by OpenColor.io. Standard sRGB color spaces are computationally narrow. When processing high-intensity digital light, like a glowing particle simulation, the math hits a hard limit, forcing the pixels to clip into flat white blocks. Here, sRGB hits a hard ceiling and clips. In contrast, the ACES curve extends smoothly. Applying blend modes like screen or add here calculates light with physical accuracy, preventing the unnatural color shifts and hard clipping that ruin legacy composites. Once the composite is built, the output display transform mathematically maps this massive dataset down to the exact specifications of the target monitor. Because the core data remains device-independent, visual fidelity is maintained identically across every artist's workstation and external vendor network. By managing the math correctly from ingestion to output, ACES allows artists to process light without degrading the original source data. The second pillar of the pipeline is Universal Scene Description, or USD. USD is frequently misunderstood as a simple file format. It is actually a highly concurrent 3D asset layering ecosystem. The LIVRPS model stacks data into discrete layers, base geometry, shading, and lighting on top. Using sublayers, animators update the bottom geometry, while lighting teams simultaneously light the layers above. Overrides allow lighting adjustments without permanently altering the referenced base geometry below. This strict data hierarchy isolates every modification. No artist can accidentally overwrite or break another department's work. For a VFX supervisor reviewing a sequence, this means they can instantly swap between different material variants in real time during look development. By structuring data as non-destructive layers, USD creates a fail-safe environment where hundreds of artists can simultaneously construct a single 8K frame. The third pillar brings this efficiency into the 2D compositing stage through programmatic automation. Manually importing 3D renders, verifying their metadata, and extracting individual image passes consumes hours of an artist's day. By utilizing Nuke's Python API, pipeline developers write scripts that execute these complex node assemblies instantly. When a new render drops onto the server, a background script automatically reads the header metadata directly from the incoming EXR sequence. The script automatically splits the arbitrary output variables into a standardized node tree, separating the albedo, specular, and z-depth passes. Because the tree is uniform, pipeline teams use live groups to push global color grade updates across every workstation simultaneously. Generating these scripts programmatically enforces a strict structural baseline across an entire episodic sequence, reducing technical quality assurance time. By removing file management from the daily workflow, the compositing team is freed to direct their focus entirely toward creative execution. Even with a perfectly organized node tree, rendering 8K motion graphics presents a final massive computational hurdle: volumetric occlusion. Traditionally, compositors relied on flat 2D alpha channels and predetermined 3D holdouts to layer overlapping objects. This is a visualization of deep compositing. Instead of a single flat color value, the pixel expands to contain multiple distinct data points, stretching backward along the z-axis, recording precise depth information for every element passing through. This means a complex 3D particle system can be passed directly through a solid volume, like a cloud of smoke, and layer itself accurately without any manual rotoscoping. If a client requests an animation change to one object in a crowded scene, only that single geometric element needs to be updated and re-rendered. Upon ingest, the compositing software calculates the exact spatial layering and occlusion automatically, using a deep merge node. Eliminating the need to re-render entire scenes to fix an occlusion issue removes the pipeline's most expensive bottleneck, saving hundreds of hours of compute time. All of these systems exist to satisfy the uncompromising delivery requirements of modern immersive environments. Outputting 8K HDR footage for an advanced LED volume requires pushing uncompressed data rates that exceed 60,000 megabits per second at 10 to 12-bit color depths. As this blueprint illustrates, the integration of ACES color management, USD asset layering, and Python automation is the operational framework required to support that scale. The modern VFX supervisor operates as the chief technical architect, responsible for continuously optimizing this entire ecosystem. Methodical, error-free data handling preserves the technical integrity of the brand, securing the client's confidence in the final deliverable. Automation and non-destructive layering provide the infrastructure needed to deliver 8K HDR content without compromising technical standards or creative deadlines.